So while the last ones are joining, welcome everyone to this session on Spring for architecturally curious developers. My name is Oliver Drotbohm. I work for VMware in the Spring engineering team. I've done Spring data for, oh my gosh, over a decade, I think. So everything that is named quote unquote repository, that's kind of the stuff that my team and I have been working on. I've moved on into some, let's say, more architecturally related work like 2 years ago, roundabout. And I want to present you on things that we've been working on, like a couple of folks within the Spring team and what we want to achieve with that, right? There's also a book coming, so we got the advertisement out by the end of 23. I mean, with books, it's the same as with software. They're usually late. But yeah, that's at least it's still planned for this year. All right, so I want to start with a bit of an introduction into some domain that we're going to look at, because it's fundamentally we're going to talk about how to build or structure applications, how to structure Spring applications in a way that it actually supports development, right? So the example domain I'm usually using in my talks is the domain of an e-commerce system, because that's something that everyone can relate to, both from a or at least from a user perspective, like you've all shopped stuff on Amazon, but also from, let's say, kind of understanding how some internals might work when you develop such systems. So what we're going to look at is just the simple process of issuing an order, and that order going through some life cycle and then eventually being completed, for whatever that means to the domain. But the particular aspect we want to look on is that that completion actually is triggering other functionality in other parts of the system, right? So let's assume we have just subdivided our very simplistic system here into these two parts, the order processing part and the inventory part that keeps track of, let's say, how many TVs are still in stock and what have you, right? So it's very, very focused on that. I guess you have more complex domains to deal with, hopefully. And the end of, let's say, such an analysis usually is you've been through some event storming, you have a whiteboard full of post-its, you've kind of come to a initial design. Okay, these are the functional parts that I want my application to consist of, and then that happens, right? So we have this developer team assembled in our room, and then we have these post-its, but unfortunately, except you work in Miro, they don't run in production. So somehow you have to translate that logical domain structure into your application code and have to arrange your code in some way that, in the best case, actually helps you developing these individual parts and developing new requirements. So let's say you're coming out of this brainstorming room, right? You get to your computer. The first thing you go to when you start a new project is start.spring.io. You select a couple of dependencies. You're building a web application here. We choose JPA as persistence mechanism, a bit of DevTools for convenient programming. That's kind of it, right? So you get some kind of skeleton. That's a technically structured skeleton, a typical Maven-based project structure with a Spring Boot main class, and one test that basically makes sure that the application bootstraps. So that's great, but now what, right? So there's no real guidance on, let's say, how you go ahead and structure your system, right? Whether you want to structure it technically or want to structure it along the lines of your functional decomposition, there's nothing that the Spring team actually gives you here, right? We've been or at least I have been promoting a certain approach to this for quite a while, but that's kind of talk usually, right? Presenting at conferences, discussing stuff in hallways, but there's no technical support there. That would be nice to have, because that would just make your life easier, right? If you got some guidance, and then based on that guidance, you actually get some help from the framework maybe to do that stuff. So the fundamental question I want to discuss here is, how do we actually represent the functional architecture in the code base? And I'm going to go ahead and explain why that or structuring your code base along the lines of your functional decomposition is an important thing. Let's do that first, actually. If you or that's basically the package structure that we often find in our users or customers projects. So a very technical separation, right? You have the domain code, and you have a bit of persistence and service layer. Especially if you've been influenced by like the core Spring abstractions with the add service annotation, the add controller annotation that goes into the web package, everything that's add repository or Spring Data repositories goes into some repositories or persistence package, and then you have this other code that's usually annotated with JPA annotations that goes into the domain, but it's also a bit of persistence. So where does it really go? And you can exchange that. That's classical layering here, with the exception of domain, but you can also exchange that with anything more modern, right? People are like, oh, we don't do layers anymore. We now do ports and adapters, or we do onions, or what have you, right? But it's still all technical arrangement, and that actually is a problem. Why is that? The problem is that these technical groupings are just sole groupings. They're not units of cohesion. The controllers in your application rarely depend on each other, right? So all the dependencies that you have to establish to actually get something meaningful done are across these boundaries, right? The controller depends on the service depends on the repository, and the repository connects to the database, right? So you have all the meaningful connections across the boundaries, not within the boundaries. So that fundamentally subverts the idea of encapsulation. Because if you wanted to design your packages for encapsulation, you would actually make sure that most of the dependencies happen within one package, right? So you want to get to a different scheme, and that's something that Dan North recently pointed out in a blog post called "Cupid for Joyful Coding." In an attempt to form some alternative to the solid principles, he came up with this Cupid acronym within, or for which the D actually stays for domain-based structure and domain-based boundaries. And he basically says that all the frameworks, the general, let's say, architecturally high-level frameworks, something like Ruby on Rails, or that's the example I think he uses. They all focus on some technical structure, right? If in Rails I think it's actions. I'm not too familiar with that space, but these frameworks usually give you guidance on a technical way, because that's the problem domain they address, right? In Spring Framework, you have the add repository annotation, you have the add service annotation, because this is the abstractions that the framework actually gets active on, right? Services are the level that you apply transactions on. Repositories are needed for exception translation, for example, from the data access technology that you're using into the common Spring data access exception hierarchy. So that's the abstractions they expose, and that's why it's not surprising that developers follow those conventions. The problem is exactly what I just described, right? That you basically have all the meaningful dependencies across the boundaries, and you can actually change that and then also make your domain more expressive in your code base by just having functional packages on the top level, right? There's no problem at all with having these technical packages on lower levels, like in nested cases, but we generally recommend to start with just functional packages on the very top level. Because in the easiest case, you could just put, let's say, the controller, the service, the repository into the same package. And then even some grad student just coming out of university will probably have learned that there is something called layering going on here, and then know, or you could even set up some ArcUnit rules or what have you to basically still express, hey, repositories must not depend on the controllers, because that's kind of the rather easy stuff, right, to control. You don't need packages for that. But it's kind of interesting to develop, let's say, a really or an idea of, like, in this case here, for customer inventory and order, in which order do they actually depend on each other, right? And that's kind of the stuff that, at least in the projects we see, usually leads to messy code bases, because every kind of functional unit is depending on any other functional unit. So you much rather want to control those things, and it's easier if you have them in well cohesively designed packages, right? So you want to get to the picture on the right and not to the picture on the left, and that's why you should start with that very simple idea, right? It doesn't sound like much, but it actually makes a real difference. We're going to see this, and having seen a lot of Spring projects or Spring projects working with that functional decomposition approach, we thought, okay, it might be nice if there was some, or there's some obvious like questions you can or follow-up ideas that you can come if you have these functional packages, that it would be nice that the framework actually supported those ideas, right? Things like, oh, can I actually test? Yeah, that's nice. Not now. It would be nice to actually be able to test these functional approaches or these functional slices individually, right? We've seen customers that move to microservices for only for the reason that they basically claimed, okay, we want to test individual parts of the system separately. Well, if you design them, design your monolithic system, sorry, getting ahead of myself, in that way, in that functional way, there is actually a way to just bootstrap that a particular functional slice, and we're going to see that in a bit, right? And there's a bit of code in a project that we've just started, and that's in experimental state right now, to support you with exactly that. I've prepared a sample repo in my personal GitHub Arc Evidence Spring. It's a repo that basically uses commits in a way that it takes you through the entire thing on a step-by-step basis. So it's not really like latest commit on top. So for today's edition, you want to check out the events / yada 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 Vox Day Zurich tag if you want to follow along. We're only going to have a look at 2 of the commits in there, because there's just 45 minutes, but the rest of it is demo time now. So, does that work in size terms, actually? If I don't hear any complaints, then we're going to go with that. So the idea is fundamentally that I have prepared the example project in just the way that I suggested, and it's kind of an arrangement. I've kind of simplified this to the very point that I'm trying to make here, right? It's not about like what does the order do and how does the inventory actually handle the orders. It's all about the Spring beans, the components, and the relationships between them, and how do we arrange them for improved modularity. That's kind of the question I want to answer. So we have this order domain class. That's just an aggregate relating to a customer identifier. So there's an entity-to-entity relationship here, and there is this order management, like a typical service that would be used by a Spring MVC controller method to then basically trigger state transitions of the order. And the interesting state transition for us being that completion step here, right? So something you're basically checking out and you're done paying, and then the order has to be processed by some shipment or what have you. There is this other module that basically just consists of that Spring service that is likely to be a repository beneath it, but it's just exposing that method to update the stock, right? Relating back to our initially given example. So that's what we start with. There is some API in Spring Modulith, the project I'm talking about basically, that allows you to basically point you have to point it to your Spring Boot application class, and you would usually do that in a test, just building up this application modules instance here. And if you run this, and you can basically then just render this to your console. If we run this, you're going to see that what it actually looks like, or what it prints out, is all the logical modules it finds in your application. So it applies exactly the packaging scheme that I've just described, right? So here's the top level package in the upper right here, upper left here. There's the top level package. It has this application class, and every direct subpackage is kind of considered a functional module by default. There's ways to tweak that with annotations and a bit of configuration if you have to deal with a different package arrangement, but that's it for now. I'm going to go into like slightly more complicated scenarios later on, but that's it. You see that, okay, that's the information it gathers. It also analyzes the packages for the code that's contained in them, right? And it finds Spring Beans in particular. It finds other architecturally relevant abstractions, things like aggregate roots. It finds events. It finds Spring configuration properties. So code that has some architectural role, and it just analyzes the dependencies between all of them, and just prints this out here, right? So bottom line is we get a logical module, a logical understanding, we meaning that piece of code here, of the arrangement. So the first thing we can do is we can, while this is nice, and this is like, I mean, a bit of ASCII stuff in here, that's not something you would actually present to some other developer or what have you. The first thing we can do is we can render this as ASCII documentation. That creates a couple of files that would then look something like this. It would basically create UML diagrams or C4 model diagrams for you reflecting your actual application architecture here, right? So the overall architecture diagram, component diagram, plus, and that's what you see down here, tables that we call application module canvases. That are kind of, they look pretty simplistic. They're going to look slightly more complicated later on. But they basically gather interesting information about the individual modules on exactly what I just described, right? The architecturally relevant entry points into your system. What services or into your module? What services are exposed? What controllers are part of the module? What aggregate routes are in here? What configuration, Spring Boot configuration properties are exposed, and what are their default values? What events are published? Going to get to that in a bit as well. Which events are consumed? All these kinds of things, stuff that makes up the surface of your application module, right? Let's play with that a bit. And it's just generated in a test case. So we refer to that as architectural observability. So you can always get an impression of what the structure and arrangement of your system looks like, and it's guaranteed to be up to date because it just reflects what you have in your code base. Let's stick with that. Let's start with something that's quite, I mean, when I say application module, what does that even mean, right? There's some form of encapsulation going on. And the first thing that a service here would probably use is, let's go with a class, call it inventory repository. It doesn't have to be a Spring Data one for now. We just make it a repository. And add that to our inventory here, and then just go ahead and add that as a dependency, private final inventory repository, and call that repository, right? So we've established, like within the module, there's like two components now, and we've established a relationship between them. So let's have a look. Let's just rerun the test and have a look at how this actually changes the arrangement. It makes the inventory repository appear in our module overview, right? Because it's a public class in here, so it's publicly available. It's available to other components or other modules. So what we could do is, within the order management, we could actually go ahead and create a relationship to that inventory repository. So is that something that we want? Very likely it's not, because the repository is an implementation detail of that would just, I think that doesn't change anything about the documentation. It's just, the point I'm trying to make here is you can easily, because of just dependency injection being a global thing, you could easily refer to something that's internal to the other module, and you would want to avoid that, right? There are tools that you could actually use to set up rules that basically say, services from this module must not use repositories from other modules, like ArcUnit. And actually what's under the covers of this application modules abstraction that I've showed you before actually is ArcUnit. It's just that you don't have, we had basically put stuff in place that you don't have to actually formulate the rules yourselves, right? Because we kind of assume a certain ideal about the arrangement, right? So we want to avoid this dependency to be possible here. So a very easy way, and actually a way that's not even related to Spring or anything at all, would be to just go ahead and make the class package private, right? And that works because we have used functional packages, right? If that repository had lived in a repository package, it would have to be public so that others from other packages could actually refer to it. But now we can just use the compiler for general purpose, rudimentary, not dependency management, but we can basically distinguish the stuff that's like externally accessible from the stuff that's not externally accessible. So we can avoid, the compiler already helps us to avoid that broken dependency here. So now let's say, I guess I can read your minds and you say, okay, yeah, well, that's a very simplistic example, right? You just have that single package. What if you actually have a sub-package in here? For some reason, you would want to have a sub-package, and you would want to have a component in that sub-package. And then the like this arrangement here, right? So that kind of stuff. And in this case, that using that package scope kind of fails, right? It doesn't work anymore because, as I said, for the inventory to refer to its internal implementation detail, the repository would have to be public. Right. So it actually has to live in the or it lives in that nested package. And let's have a look at how the that changes the picture of our documentation. Let me refresh that. Reopen. Something's gone wrong here. Yeah. You see the repository is gone again. And that's due to the fact that we implement a strategy that's pretty common in alternative like modularity approaches like OSGI or JPMS, where you basically specify packages that you want to export explicitly, right? And in 90% of the cases that I've seen, there's always this, oh, here's one API package and all the other ones are kind of not exposed. And that's the default we assume. So the fundamental idea is that you put all of the stuff that you want other modules to be able to use in the very base package of your module, and everything else is hidden by default. You can then selectively add some configuration to export other packages or other types as part of the API. But by default, that's basically what we assume here, and that's also why the internal component doesn't show up in the documentation here, right? It's an implementation detail of the module. It's not of the business to other developers outside of the module, so that's why it's not listed as entry point here. It not showing up in the documentation doesn't unfortunately prevent us from reintroducing that dependency here, right? That would still work. Remember, the compiler helped us when we were able to actually package scope the repository. There was the compiler that basically said, okay, you can't actually see that other type. So we can do that now because it has to be public. So what do we do about this? Either write our own arc unit rules or basically just call that verify method on the modules here. And if I run this, this test should fail now, and it does. Because it basically says, the first line is the interesting one, module order depends on non-exposed type inventory repository within module inventory. Right? So you get some next level check of your dependency arrangement with these conventions applied, right? And you have to note here, we haven't declared any kind of additional metadata at all, like no configuration of the tool yet. It's just like, okay, you just arrange your code for encapsulation, and then you basically get the verification for free. And it also means that until now, that production code side here, the source main Java thing, is a Spring Boot application as it was before. There's no references to anything Spring Modulith so far. So it's not, at its very core, it's very non-invasive to you as a maybe seasoned Spring Boot developer. That's kind of the idea here, right? So try to be as less invasive as possible, but at the same time give you all the architectural benefits for now. So that's the verification stuff. You can achieve that part of the story with other approaches as well, right? The typical thing that's brought up is build modules. Yeah, of course, you can actually have use build modules for that, and Spring Modulith would still work with them. You don't necessarily need that verification then anymore, because you're forced to declare the dependencies explicitly, and then you can have your API module and your implementation module. But for smaller applications, I have this other thing that I do with, there's an example project for Spring Modulith with the TU Dresden. There's like 15 logical modules in there. If I had to declare an API and implementation module for each of those, I end up with 30 build modules and a lot of like build descriptors. With modules, ending up with modules with a single type in them, that's a bit of an overkill. So whereas like in bigger projects, it could be just very well a good solution, right? The build modules. So it's not an either or, it's more of an, okay, what's the easiest way to achieve something here? And that's why it's kind of put in that verification stuff. All right, so we have, let's move on. We have, what's the final state of, or we have to repair, basically resolve our architectural problem here by deleting that line of code. That's always the best solution, deleting or solving problems by deleting code. So we have our arrangement here, and yada yada. Let's go back to the command line output. We have, you've seen we have these 3 modules here, and they currently they don't have a dependency really, or like a dependency. There's no dependency between the modules. And what's kind of nice is that we can now go ahead, or let's say we have a model of the module arrangement, and we can use that model to bootstrap integration tests, Spring Boot integration tests for the individual modules, right? And we do that by, if you've used Spring Boot before, they have a feature called slice tests, where you can actually horizontally, again, like technically, test individual layers, right? You can have the add-data JPA test that would just bootstrap JPA repositories, or you have the I think it's web test or something like that, web MVC test, I think, that just bootstraps the controller level but expects mocks for all the services the controllers are using, right? So it's again horizontally oriented, because that's the only structural information that Spring Framework or Spring Boot can actually have, unless you have a functional separation model in place like we have now. And that's why we can actually go ahead and say add application module test. That would basically, from this very package, would try to find the application class, right? Would just try to traverse them to the top, find the Spring Boot application class, build the application module model from that, and then look at, oh, in which package is that test actually located, and it would try to bootstrap only that module. And you can see that in the log output. If you run this, it basically prints out like what it's doing. So it's an application module test for the inventory in the mode standalone. So we're trying to bootstrap a single module only, and it basically prints out all the stuff that or the modules that it actually bootstraps. I'm going to get ahead on that in a second, right? And the interesting output here is basically this, right? So we want this test wants to bootstrap the inventory module, so we tweak the Spring Boot startup to only apply the auto configuration and the entity scanning to the code that's located in the example.inventory module, right? And that's kind of, it's like bootstrapping Hibernate with a certain subset of entities and whatnot. It's a complete integration test, but just like strong vertical slices here. That's it. Let's add some. For the inventory, it's kind of nice and easy because there's no outgoing dependencies to it, right? Let's add some dependency, like a valid dependency, actually, private final inventory. Because you remember we wanted to, at some point, trigger the update of the inventory. So the order management obviously has to, or not obviously, but it has to have a dependency to the inventory for now, which basically changes our, let me render the documentation again, and refresh that, which should, yeah, so the order module now uses the inventory. See that up here? Whoa, 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 whoa. It uses the inventory. It means that we have a Spring Bean relationship across a module boundary. going to come back to that, right? Why this is important. And if we now start our order integration test, I guess you can follow that this would have to fail, right? Why does that have to fail? It would try to bootstrap the order package and all the Spring Beans located in that order package. And that means it would have to find a bean of type inventory to satisfy the dependency here, which it shouldn't, right? So let's run this test and see how it fails, actually. Yeah, as expected, no such bean definition, qualifying bean of inventory is available, which is expected. But what do we do about this? There's two things you can do. One is like the standard Spring Boot thing that you would do in such cases. It's you would provide this thing with an mock bean inventory. And I like this stylistically quite a lot because it basically, what you express here is, oh, to run the order module, I have to mock the dependency to that other module, right? If you're developing microservices and you have relationships to other services, then you have to wire mock those, right? It's kind of a similar idea, but without all the network and all the infrastructure stuff in place here, right? So you mock the other component, and then this test bootstraps just fine, right? You see it's green here, that works. Another thing you can do, and that's an interesting part, and that sets apart like other or it sets apart this stuff here from other modularity approaches, is that you can basically say, I want to bootstrap not only the application, that individual module, but from all the modules available, the ones that I depend on, and either in a direct step, which in this case would just work, or I want to select the entire subtree of modules that I need to actually bootstrap to get my module to work. It's a key differentiator to for example, things like the Java module system, right? That has a very different way of approaching integration tests. And that would actually, that different bootstrap mode is reflected in the log output, because with all these customizations, it's kind of, okay, how do I find out what's actually running here, right? So it basically says, okay, mode direct dependencies. This is the module that we're trying to bootstrap, and we transparently include for you that other module as well, right? And there's means for you to actually say, I want this particular module to be started alongside with all the others, although it's not directly related. You can formulate that, but there's a nice way of basically gradually increasing the scope of your integration tests, depending on what you want to do with that. All right, so how many minutes do I have left? Someone tell me. We started at 10 minutes. All right, so there is, that's the integration test feature. We're going to expand a bit on that in a bit. I have to, let me go get YOLO. Steps, I think it's 01. It's got to be, yeah, that's the right one. Fast forward a couple of steps. Let's remove this. What I've added here in this step is just a sample for Spring Boot configuration properties that are just located in the inventory package. And let me just run the documentation generation for you to see a slightly updated yada yada. Why is that so tiny? For updated documentation, you see that we now have this properties section in here that basically documents to your casual reader. If you have someone new coming to the team and you basically tell them, oh, you need to work with the inventory module, and they kind of have to find out, okay, what can we actually configure about it, and what are the interesting aspects of it. There's a bit of just meta information for you to extract into the documentation. What's also happened is we now have moved to event-based communication between the individual application modules, and a large part of Spring Modulith as a whole is supporting that integration style, because if you find yourself, or these functional or these business events of order completion, they usually develop some kind of functional gravity that cause you to having to like build up a lot of dependencies for those, right? If you complete an order, you want to update the stock, you want to send out emails, you might have to, let's say, update some bonus points on some rewards program, and you can have an entire team building that functionality, but you will have to go back to that bloody order management complete order method to actually to add the dependency to invoke that very method, right? And the same way, you don't want your microservice to reach out to 15 different other microservices to achieve some business result. You don't actually want to do that with like Spring Beans, at least across module boundaries either. So the idea is that you fundamentally switch for these cross-module invocations, you switch to event-based communication, and there's a bit of Spring Data support for publishing application events in Spring. That's a feature that's built into core Spring. There's nothing Spring Modulith specific about. But what we do here is we basically just trigger a state transition on the order aggregate saying, oh, we register this order completion event, and that automatically gets published when we interact with the Spring Data repositories calling save, right? Because that's kind of the unit of work is completed, and then that triggers that event. That has the nice side effect of as I usually phrase it, the side effects of that invocation, they end within the module, right? They're not like sneaking out into the other module, and the order management by that gaining the task of having to know what else has to happen, which is that's not the purpose of the order management implementation here, right? It's rather saying, okay, I trigger my state transition, and then I'm basically telling everyone else what I have just done. I have completed the order, and then everyone else is free to react on this stuff. It's kind of like it's literally applying the idea that you have in, let's say, event-based Kafka messaging-driven system to the interaction within your application as well, right? And so the side effect ends in the originating module, and it could be, or it would be picked up by something that's called application module listener. That's what we call it. That's nothing but a bit of syntactical sugar on the combination of add async and transactional event listener with requiring a new transaction. So that transactional event listener causes the event to be submitted only when the transaction commits. And the reason for that is that you want to make sure that the original module actually has concluded their business task. You don't want to send out an email saying, oh, the order was completed, with the chance of the transaction to still roll back, right? That's kind of the idea. And the reason for it, for those to usually run async, is that, oh, sending out that email, for example, might take a while. You have to interact with some email server. So yeah, you rather want to take this off the actual main execution thread. There's a bit of a risk involved here. The application might just crash, right, while you have completed your original transaction, and you in the middle of sending out an email. There is support for that scenario in Spring Modulith called an event publication registry that would actually make sure that you're not losing the event publication right within your simple like JDBC local transaction arrangement. But that's a bit too far ahead for our 7 minutes left. What I would like to show you is how you actually integration test this stuff, because we've like put significant effort into providing you means to do that. And there's like two ways. One is the let's stick with that for now. One is the let's say the more bare bone way of trying that stuff, which is you can have an abstraction called published events, or in this case, if you're using assert_j, assertable published events as a parameter to your JUnit method, and then you can trigger your application logic, in this case, the order completion, and then you can expect, or what that published events abstraction does is it collects all events that are published in the system while that test method executes. Right, so all the events are kind of captured, and then you can basically filter and match on the events that were published. So you kind of, in this case, what you're describing here is, oh, assuming I'm triggering that order completion, I expect an event order completed to arrive or to be published with the ID in that event matching the order identifier. That's kind of the thing here, right? And we've had that for a while, and we've basically come to the conclusion it would be nice to actually turn this into a slightly more reasonable or more readable and more, let's say, high-level description, especially when it comes to asynchronous application invocations, because then you're pretty quickly at a tool called availability, which kind of allows you to basically say, execute some code and then wait until something happens without having to do all this thread sleep dance yourselves. And what we came up with is that we call it scenario API, where the entire test case is kind of encapsulated in this, right? So there's the notion of, okay, we stimulate the system or stimulate the module with some method invocation, with some event publication or what have you. There's, I think, another method called publish, where you can just shove in an event, and then you can basically describe like what you actually wait for to happen, right? There's like wait for event of type order completed, matching mapped values. So that's kind of the description of what you're waiting for. And then you conclude this with to arrive. And there's like additional overloads that basically say to arrive and verify. So you could basically still get the event that you're waiting for and then execute some other code on it to verify. Or in this case, you can even get, for this one here, you would even get the thing that the stimulus actually created, right? The result of the initial operation. And that's kind of neat to you really get to very brief descriptions of. Do we have that in here as well? No, I think I have to check out. Go git co main. There should be a couple of more in there for that. So there's oh yeah, that's like a slightly more complex scenario. We're waiting. In this case, this is example of the event publication registry that's in use here. It's kind of the test is showcasing how it reacts to a failing event listener, and it's basically our stimulate the system using order completed, and then we wait until the exception actually is created in the listener, and then we verify that we still have that event publication in our event publication registry. Technical details aside, I think it reads pretty fluent, and it gives you a very neat API to actually describe how you want your module to behave, right, in an integration test scenario. So it's like using transactions. It's not like some unit testing thing going on here. It's like a full integration test in this case. All right. To recap, fundamental idea is we use packages as the driving factors for our functional decomposition. Good fences make good neighbors, right? So try to keep stuff in package private if you can. If you have to or want to use, let's say, ports and adapters packages, then use them below the functional decomposition, right? Whether you use layering, whether you use hexagonal architecture, is an implementation detail to the very module. You get a simple set of access rules and APIs to verify. There's a related project going on here called jMolecules that has a lot of the DDD abstractions within them. Spring Modulith will actually verify that your DDD module or abstraction arrangement actually follows the rules that you, for example, find in Vaughan Vernon's book, Implementing DDD. It will find cyclic dependencies between modules, all this kind of stuff. Think of it as a pre-packaged set of ArcUnit rules that you get out of the box if you just follow those conventions, and you of course can tweak those conventions if you need to. Integration test support for individual modules or like multiple modules at once. There's the event publication registry that allows you to move your module interaction to event-based interaction and not risking that you lose events in case of the transactional arrangement kind of failing, infrastructure interaction failing, or what have you. Documentation support. You've seen the diagrams, you've seen the application module canvases, and something I didn't have the time to go into is if you have a microservices arrangement and you build your order and your inventory system as separate services, you usually put something like Zipkin or some tracing in between to see how the modules interact and like which thing is causing, or the event here is causing that other thing to be called. We have built the same thing for the logical modules here. So if you add there's a couple of jars that you have to add that to your project. They will pull in the micrometer observation support, and you will actually get the same traces showing you, oh, there was a request entering the order module that has triggered an event, which has triggered some functionality in the inventory module, in the same way you would see that if they were separate services, right? You get an extra layer of depth insight into your application interaction. That's it. I'm on time. Am I? Yeah, I think so, right? I mean, if there's a question, I think we can answer one. Is there a question in the audience? I can hardly see any one of you. Is there anyone there even? You've been so silent. Oh, I hear some people laugh. Any questions? Oh, there's one over. Oh, where's? Let's take this one because the microphone is over there. But I'm happy to talk to you later on. Go ahead.
This event design or event-based development you have
Yes.
in the Modulith, I like it very much. Well done. The question is, why do you have this coupling between Modulith and event-based approach? I think this could be designed in the way that it's fully decoupled, so that anybody who is not using Modulith can benefit from the approach and the design you have made in the event development.
That's a good question. So its microphone has been recorded. I don't have to repeat it. So of course you can work with Spring application events without Spring Modulith, right? There's just certain error scenarios that you might want to trigger, or that you not might want to trigger, that you might run into, that you have to find a solution for. For example, the original business method committing and the event listener failing. So then you kind of, what do you do about this, right? The order completed event is gone, but you still have to send out that email. And there's a bit of glue code that kind of plugs into the Spring event publication mechanism that would write like a log entry. Oh, we have to submit this order completion event to the email sending event listener with the original business method, and that entry stays there until the listener has completed successfully. So there's just that tiny bit of glue code that you would otherwise have to come up yourself with yourself, and like we don't feel comfortable telling everyone, oh, just go ahead and use this event-based interaction, but there are other problems that you're going to run into, and you now solve them, right? We're not exchanging one problem for another, and that's kind of why it's in there. Fundamentally, I think we could even move this to framework at some point in time. I mean, right now this project, there's a predecessor of the project that's been used in production for I think a year or two already. We've just moved it to be a actual Spring project, and it's in experimental status for that reason, because it's just like been moved over. But I'm hoping to get it basically elevated to non-experimental by the end of the year. So yeah, fundamentally, if you've asked for that, why event-based in the first place? The reason is that you can hardly get your modules to be testable if they have to basically reach out to other modules all the time. It's similar to in a distributed systems arrangement. You don't want like to wire mock all the other services or run them or what have you, but rather it's this temporal decoupling, literally, right? You don't have that other thing to be available for you to complete your very own business logic. That's kind of the idea. And you don't have to actually move to a distributed systems arrangement to get that kind of programming model. That's kind of the thing. And it's not that I'm saying the other thing is wrong. I'm just saying it is a different trade-off with different costs. And it's still fine for you, and actually that's what Spring Modulith helps you with, is to prepare your system in a monolithic arrangement to, if the point in time comes where you actually have the requirement to scale one thing in a different way, then it's much easier to basically decompose that modular system, monolithic modular system, and extract one thing out, and then basically just put a Kafka in between if you're already using that event-based interaction model in your monolithic application. And with that, Thank you very much. Enjoy the rest of the conference. I'll be around for this afternoon, so I'm the short guy with the hat. So thank you.